Hi, today we're going to talk about triangles, introducing a whole other shape to our arsenal. Now, triangles are one of the simplest shapes. They consist of three line segments joined together. And of course, you've already seen the typical triangle. Looks a lot like this. But today, we're going to go a little further, examining all the basic properties of triangles and why they exist. So, let's start with the most basic properties of triangles. The way that they look. Now, there are a couple of variations of triangles, and we classify them into a couple types. So first, we like to classify triangles by their angles. And if you remember acute, less than 90, right, 90, obtuse, more than 90. If you remember acute angles, right angles, obtuse angles, we refer to triangles by those that have those angles. So, for example, we might call this, where these are all, where these two are less than 90, right, acute. Triangle like this, we have a right angle. Well, we would call that a right triangle. And triangle like this, where we have an obtuse angle, we might call it an obtuse triangle. But more common than that is referring not to triangles by their angles, but by their sides. Because there are a couple of very common triangles that you see depending on their sides. The first, and the stereotypical triangle that you'd see, is what we call an equilateral triangle. And that's where every side, all three sides, are equal. They're the same length. And in geometry, we notate having the same length, basically these little lines, right? And this means, hey, this side is equal to this side, and this side is equal to that side, and they're all equal to each other, right? We also see isosceles triangles, right? This is where two sides are equal, but the third's not. Write them down here just so you can see them written. And finally, well, what if none of them are equal? Now, obviously, this isn't perfectly the scale, but we call these scalene triangles, where none of the three sides are equal. Now, what does this mean practically? Well, we're looking at sides, but this also has a hidden effect on the angles. What do I mean by that? Well, in an equilateral triangle, all the angles are going to be the same. In the isosceles triangle, well, two of the angles are going to be the same. Scalene triangle, well, none of them are going to be the same. But that leads to the question, well, what actually are the angle measures? What do you get when you add up all the angle measures in a triangle? Do you get 360 like you do in a square? Well, that's where things get interesting. And that's why we started first with squares and rectangles. Because let me draw a square. Let me say I want to cut this in half. Well, hold on a minute. Let's look a little closer. I know these are both right angles. But if I were to separate this out, don't I actually have two right triangles? I do. And we might say, okay, well, that's just for a square. What about a rectangle? Well, for a rectangle, we see the same thing. If I were to separate this out, I have two right triangles. And now, where does this come into talking about some of the angles in a triangle? Well, if the sum of the angles in a square or a rectangle are 360, and I can make two triangles out of a square and a rectangle, well, then it stands to reason that the measure of the angles, the sum of the measure of the angles in a triangle is going to be half of what they are in a square or rectangle. We know that in a square or rectangle, these are 360. So in a triangle, then, they're all 360 divided by 2, which is 180. 180 degrees. This is one of the most important properties of triangles. Every triangle you can draw off or think of, its angle measurements sum to 180 degrees because they are half a square. They are half a rectangle. Since rectangles are 360, triangles are 180. And this works for every single triangle you could ever think of. So, that covers the basic properties of triangles. But that doesn't mean we're done. There are a ton of other interesting properties of triangles that will definitely help you out later. So in the next videos, we're going to talk about them. But that's all for this video. I hope you enjoyed it. I hope you had fun, and I hope you have a great day. Thanks for watching.